Right now, we're sitting at 118 miles high, barely past the Kármán line, the start of outer space, in a parking orbit. We can't stay long. Earth's atmosphere still drags on the spacecraft. Without action, our orbit decays and we fall back within hours. To reach the moon, we must cross 240,000 miles of vacuum to hit a target constantly speeding around the Earth. This transit introduces 500-degree temperature swings, complex gravitational traps, and stretches of complete radio silence, where the crew is cut off from any help on Earth. Surviving this environment required building a constant sequence of workarounds into the flight plan. The first hurdle is breaking out of Earth's gravitational grip. To do that, the third stage engine fires for a massive 6-minute continuous burn known as the Translunar Injection. This push sends us away from Earth and toward the moon, rendering the massive third stage of the Saturn V rocket completely useless. However, the Lunar Module, the actual ship designed to land on the moon, is still packed away inside the adapter panels below us. We have to extract it to continue the mission. The Command and Service Module detaches, flies forward, and performs a 180-degree turn. It then carefully glides back in to dock nose-to-nose with the Lunar Module. Once locked in, the Command Module fires its thrusters and pulls the lander free from the empty rocket stage, assembling the spacecraft into flight configuration. The crew had to perform this sequence perfectly just to get the required vehicle pieces out of Earth's orbit. Now that we're cruising through deep space, we hit the next hazard, thermal regulation. Without an atmosphere to distribute heat, the side of the spacecraft facing the sun would rapidly overheat, while the opposite side froze. To manage this, the spacecraft was put into a slow, constant rotation, about 3 revolutions per hour, to evenly distribute the sun's heat. This was famously nicknamed the barbecue roll, but there's always the risk that the main engines could fail halfway across the 240,000-mile void. Mission planners used a path called the free return trajectory, relying on lunar gravity instead of engines. If the engines failed, this figure-8 loop would allow the moon's gravity to slingshot the spacecraft safely back to Earth. By aligning their flight path with lunar gravity, navigators turned the moon's pull into an automatic safety net for the crew. Approaching the moon, the spacecraft is moving too fast for lunar gravity to capture it. The crew has to fire the engines to hit the brakes. This braking maneuver, the Lunar Orbit Insertion, must happen while the spacecraft is behind the moon, where the mass of the rock blocks all radio signals to mission control. As the crew initiates the engine burn, they are completely cut off. Engineers on Earth have to wait in total silence to see if the spacecraft emerges on the other side. The tension breaks when the spacecraft clears the far side and radio contact confirms they are successfully captured in lunar orbit. One astronaut remains in the Command Module. The other 2 board the Lunar Module, detach, and drift away to begin their descent. The lander fires its descent engine for 30 seconds, dropping the craft from high orbit down to 50,000 feet above the craters. During the final descent, the crew faces a visibility problem. The spacecraft's design initially points the windows straight down at the ground, making it impossible to see the landing zone ahead. To fix this, the lander pitches upright in the final stage. This gives the astronauts a clear view to manually steer away from boulders before their limited fuel supply runs out. Every phase of that descent required executing blind trust in orbital mathematics before human vision could take over. With the fuel gauges near empty, the Lunar Module settles onto level terrain, ending the descent. The crew steps onto the surface, plants the flag, and begins the scientific work they traveled 240,000 miles to perform. They collect geological samples from the hazardous rocky terrain they spent the last few minutes of the descent avoiding. The moon landing succeeded because of a chain of perfectly timed engineering workarounds that began the moment they left Earth's parking orbit. But while they survived the trip out, the astronauts are now standing on a dead world. They are facing their final challenge, figuring out how to launch off the surface and get home.